This is the last function I'm going to review for the smart charging, and this is actually one of the first ones you run, but I just went in reverse order. And this kicks off all the processes, the function calling to write the start times, as I was talking about earlier, and also, most importantly, send the email notification that if I forgot to plug it in, and it schedules the charging. So this runs for both vehicles, so I'll just cover it for one, and just call it notify if is M3 plugged in. And so the first thing I do is I check to see the timestamp. So earlier, not only was it important to see the timestamp for my own notification, but this function looks at it to see when the last time it was updated. And so if it's within this is within an hour, it will skip it. Otherwise, it'll actually run that big function that checks both vehicles, writes all that data in to get the calculated start times. And then, then actually, unfortunately, I have to repeat the call because in case it was already updated, it'll skip this and I won't have this data, but I'll get this data back. So I'll get three pieces of information. One is if the charge port door is open and what the current battery level is and the current range is, and I'll use that in the email. So the charge port door opening, there's actually a few ways you could probably tell if it's plugged in or not. But I wasn't too clear on some of the variable states. But what I think is pretty reliable is that usually if you leave the charge port door open, it'll close by itself. If it's plugged in, it won't close. So I think that's a pretty reliable way of telling if it's plugged in or not. So if it's not open, then more than likely it's not plugged in. And so if you look here, I use that information to determine, is it plugged in? If it's not plugged in, then it's going to send me this email that says your car's not plugged in, and then it gives me some useful information that determine if I actually want to go and go plug it in or not. What's the current percentage battery, and then what's the range, and then you could put your Google Apps script has a way to send the email, so you could send it to this email address and then give it a title, and then it'll plug in that message. So that's a nice way to remind me if it's plugged in. And then this last part, as I said earlier, I check to see if the car's at home, because if you're on a road trip, chances are you could be driving or at a location where you're not plugging it at night. So it doesn't make sense to schedule the charging if it's not at home. But if it's like a typical week where you're commuting to work and going to the same place, have a routine, you park at home to charge it, then this is the thinking behind doing it this way. And I also noticed that I added this extra one recently, and I might take it, delete it, but this looking at the charge state. So I noticed this sometimes, this situation where I plug it in and I charge it to the right level, and because it sits there for a couple days, it drops by like 1 mile. And so technically speaking, it is at home, and it would the state of charge is less than target by, let's say, 1 mile. It would schedule the charging, but I find that to be kind of annoying, so I don't actually want to charge it in that case. And I noticed that after it's charged and it's sat there, it'll have this charge state of complete. So I also added this check to say if it's also complete. If it's not complete, then you can actually schedule it. Otherwise, skip this scheduling. So that was just a little feature I added recently just to play around with it. Again, I may remove it later, but I found that in that situation it was helpful. And like I said, if it meets these conditions, that it's at home and it needs to charge, it'll schedule it, creating the triggers that I showed you earlier. And then it also has this the typical try catch block, right? If it's asleep, which it typically will be, it'll wake it up and then run this block again so that it'll execute these functions. Now I'm going to cover the functions that help me write this telemetry data into this spreadsheet, as I covered earlier, and all the different calculations that go into that. And in the code here, I'll just cover one car, but it's the same for both, called the write M3 telemetry. So as usual, I put it to this try catch block because when I call the APIs, the car will be asleep. It's going to fail, so it has to rerun this, wake it up, and then rerun it. So I go get the vehicle state. You can look up in the APIs how to get that, what comes with that information. And so I pass in the vehicle ID here, and then this is the object, the array I want to use to put all my my data I want to insert into the spreadsheet. So I'm just declaring the variables here. So I grab the data, and this open row is what I use in previous functions to find the next empty row to write write it in. So I find, the last row, and then make sure I don't overwrite any data. So in here, in the data, I'll write things like the odometer reading, right? So the vehicle state will give me the odometer reading, and then I will put in the date here. So in here, you could see here, telemetry column A and column B, and then I find the open row here. And so it'll go to the spreadsheet, and it'll scroll down and say, okay, for column A, where's the open row? It'll write the odometer reading, and it'll write the date. So, and then you could format the date however you want. So I chose locale date string. So that's how, it hasn't written it yet, it just puts it into this object. You want to batch write it to make it the most efficient. And then I also have formulas. So from C3, or starting from C3, G3, which is the top row, going all the way down to the current row, the empty row I want to be on here. It'll copy this formula over. You can see here, it's kind of a long formula, all the way over from C to G to whatever row that I just inserted. So here's C, and then if I scroll over, these are all formulas all the way to column G. Okay, so the day is just for one of the charts. It runs this spreadsheet for me to figure out what day of the week it is, so I can know like an average by day. This daily mileage is just the difference between the odometer readings. A weekly average is just that. It takes a running average. Days in service, it takes what day I bought the vehicle on, and then calculates how many days it's been since the car's running, which is really used to get this figure, which is an average or estimated annual mileage. So those formulas get copied down automatically by that formula, so I don't have to do that manually. And this next block of code is a little bit more complicated. So it's really trying to figure out what's the mileage I'm going to start with at the beginning of the day, because I use that to figure out how many miles I've driven, to compare that against the odometer difference. And so I look at the starting range, and this I figure out if it's going to charge or not. So if the range is larger, the starting range is less than the end of day range, meaning that it's not going to charge, or there's no trigger, right, that I've created earlier, then that means I'm not charging it. So whatever range I have at the end of the day will be the starting range I have tomorrow, because it's not plugged in, it'll be the same range. So that's how it figures it out. If you look at the spreadsheet here, that's what it puts into the starting range here. So in some days you could see I do charge, and other days maybe I don't, because it's not, you can see how the end of the day range is equal to these two values, because on this particular day, and it happens to be a Sunday, I didn't need to charge it. So that's why these two values are the same. I didn't plug it in. But you see the next day it jumped up because I actually plugged it in as a work day. So that's sort of some logic I use to get around the fact that these aren't, if you haven't noticed, these aren't event-based APIs. So it's not like when the car is plugged in, it'll send this information to me and I could log it down. I have to call the API to read it. So it's not the most effective, because unless you want to ping it every 5-10 minutes, which will really kill the battery, you have to sort of base it on a schedule. And so this is sort of the best way I could figure it out. Now, and this is the same reason why that if you're on a road trip or something like that and you don't have a routine, these sort of things won't work, because depending when you call it, the car could be driving, it could be all sorts of different places. But if you're on a routine, where you're driving sort of to and from work, and you always park it at home and you always charge it at a certain time, this is the best sort of application for this type of usage. So that's where I figure out whether my starting range at the beginning of the day is what mile it is. Now, of course, I could wake up the car in the morning and then check it as well, but I figure, usually by nighttime, I'm not waking up in the middle of the night and changing something. So everything's sort of set by the nighttime when I'm about to go to sleep, and then the car's kind of ready to go to be charged in the morning. And if you look down here, this is, once I figure out what the starting range is, then I write in what the, what the starting range is for the previous day, and then what the range is that ended up at for today. So that's why there's this sort of -1 row. You can see how it writes it for the next day, and -1 is over here. So it'll write it for the next day, and then for the current day, this is what I ended up as. So that's where these values are slightly different. And again, I have more formulas, J through L. So these are more calculations. So range used is where I subtract the starting range at the beginning of the day and the end of the day. The efficiency is the ratio of this range compared to what the odometer said. So I think this is actually kind of a clever way to get an efficiency, because if the odometer says you drove 46 miles, but you used 51 miles of range, then clearly some of that went to either you drove faster or harder than the typical consumption for the rated miles or rated efficiency, or you use Sentry Mode a lot, or you ran the HVAC system a lot. So I think this will give you a good indication of that. And then you could also reverse calculate this energy use, which is in the car, but you can't read it. So I actually compare it, and generally this is higher, which leads me to think that this is more accurate because it captures things where you're just sitting in the car, you're not driving, and it's using the battery. And that number that shows up on the screen, the console, is actually based on your driving efficiency, not necessarily your overall battery efficiency. So those are those efficiency calculations that I've written in here. And then you can see here that once I have all this data, I'll batch write it to the spreadsheet here, and then everything gets sort of populated, and any formulas get copied down. So that's how I track the telemetry information. Oh, I forgot this part here. This is interesting to see the temperature data inside and outside the car, since it's there, to know perhaps on hot days, maybe that's what contributes to the efficiency difference, because you've run the AC a lot, or vice versa. On a cold day, you probably run the heater a lot, so that might be another reason why the efficiency is lower. So it's just good information to have, since it's already there, and to kind of compare it to see how it affects your range and your efficiency. Also wanted to quickly cover two of the supporting functions that were called up previously, and one is finding the open row. So giving, you pass in whatever sheet you want, the sheet name, and then the range you're looking at. And so it's really the column. And so if you look at, whatever column, it'll grab the values out of there. And if there's no values, then it's completely blank. Then it'll return you the number 1. And then, so you can write in the first row. But if it returns any other number, meaning there's actual values, it'll give you that length, if you will, the number of items in those rows, +1, so the next one, and then you can write in that row. So that's how I figured it out. I think there's actually a function in Google Apps that tells you when the next open cell is, but I hadn't had time to research it, so I just quickly wrote this. And then this other one, does the trigger exist, I used up above. So you can actually use one of the utilities in Google Apps to get all your project triggers, and then figure out whether whether that name of function, you can call it by the name if that exists, and then check if it's already been created. So the last part of the scripts I wanted to cover is around the logging. Now, Google Apps Scripts, they do have logging available, but I wasn't able to figure it out, and I don't know if perhaps it's because you have to pay extra for that. I don't know. And but it's simple enough to set up your own. So I created another Google Sheet to log all the errors, and the errors are really from those try-catch blocks, and the majority of those errors are really is a warning they throw when the car's asleep. So there's not too much events in there, but it's good to go back and see if there's something that went wrong. And so it's a pretty simple function. It just gets the logging spreadsheet ID, it gets the right tab, it finds the next open row, so it pens it and it writes the date over here, and then the message, and it looks like this. So like I said, these are the dates, and then the exception message shows up here. And you can see that most of these are the actual, like I said, giving a warning that the car was asleep. And occasionally there's some errors here because I was debugging or troubleshooting something. And so that's the error logging spreadsheet or function that I put to the spreadsheet. And then because I don't need to look back as far, I want to also trim the spreadsheet so that it doesn't grow too large. And so I run this function on a weekly trigger, and all it does is really trim the last, keep it to the most current 30 days. And so what I do is I get all the rows back from the spreadsheet, and then and as you can change this, of course, I set it for 30 days prior, so that's the kind of the cutoff point, and then I loop backwards through that array of rows to find out whether any of the, wherever I encounter first the first 30 days, the first cutoff period. The reason I loop backwards is because it's in chronological order from top to bottom, from the first row to the last row. So going backwards gives me essentially the cutoff point, the last point I want to keep the information. And then everything above that row is what I want to delete. And I tried a couple ways to do this, and I think this was the best way, because if you delete rows in between, then it re-indexes, I think, the array. So that got really confusing. So the easiest way for me was to loop backwards, find the very last day of 30 days prior to now, and then just delete from that point upwards. And that seems to work. That seems to work pretty well. So that's what it does. It figures that that 30-day period, and then just deletes everything, from that point on. And that's all the scripting that's there. It seems like a lot. It took a few weeks to write it, but like I said, it's kind of a fun project. And I'll also show you in another video, sort of another spreadsheet I was able to use using some of the odometer information to calculate, savings that I've achieved through not buying gas, essentially. So that's kind of a fun spreadsheet. I'll share that in the next video.